Today's lesson is lesson number 5.4 out of the Decimals and Fractions book. And if you're in Mrs. Walker's class, these notes are being put into your math notebook on page 45. You might want to pause here for a second and enter that into your table of contents. So, page 45, lesson 5.4, and the title is Dividing Fractions. The lesson before this was multiplying fractions, and now we're dividing fractions. You may notice that there isn't a lesson for 5.1 and 5.3. Those are multiplying fractions using modeling and dividing fractions using modeling, and we cover those in our WIN math classes, not during core, so I don't have notes for those two. So it's not a mistake that those are missing and that we're skipping a lesson. That's intentional. So anyway, today, 5.4, dividing fractions. Your warm-up today has 5 problems. 5. Okay, 1, 2, 3, 4, and 5. 5 problems. Okay, the first one is, looks like we're going to be reviewing what we learned multiplying fractions yesterday. So the first one is 1/3 times 2/5, and you'll remember yesterday I talked to you about I'm not using the little X symbol for times. I use the dot symbol for times. They mean the same thing, and we'll soon be pretty much just dropping that X. So we'll just kind of start getting used to it now. 8/9 times 3/7 is number 2 in your warm-up. Number 3 is 5/6 times 3/4. Number 4 is, what is 3/4 of 2/3 foot? And number 5 is, what is 5/8 of 1/10 mile? Now, here's where you should pause and work these out. Make sure you understand how to do these before you continue on with the division lesson, 5.4. If you're having any trouble remembering how to do any of these, go back to the 5.2 lesson and review that. Once you're comfortable with these warm-up problems, then you're ready for today's lesson. Okay, so we need an I can statement. And our I can statement for this lesson, what we will be accomplishing for this lesson is, I can find quotients. Quotients are the answers to division problems. I can find quotients of 2 fractions. Okay, that's what we will be learning during this lesson. All right, and I like to take my dark green pencil, underline all the way across at this point, and we start with the notes for today's lesson. So I have 1 notes cut out that I will be putting in our normal starting position and gluing that in with tiny tadpoles. That's what we learn in my class, how to make sure that it's just tiny little smears in the center, in the corners. Too much glue makes your paper wet, makes your pages stick together, makes it so that you can't write on these, and it's just wasteful. So we learn how to glue correctly, and we don't have a problem with any of that. All right. Okay, so dividing fractions. We got our notes in there. All right, so Dividing fractions is pretty much the same thing as what we did yesterday with one new step added into it. And I'm going to take my yellow highlighter and just highlight this so it stands out to me. These directions right here are showing me how to divide fractions. All right. So with my blue highlighter, I'm going to circle this first fraction. And then I'm going to circle the first fraction over here, because I want you to notice that the first fraction, or depending upon how they're ordered, the dividend, the number that is being divided, doesn't change. What does change is we have to turn a division problem into a multiplying problem before we can divide. You can't really divide fractions as it is. We turn this division problem into a multiplying problem. And once we've done that, you already know what to do, because we learned how to do this part in 5.2. Correct? But there's one little step that we have to make. We can't simply change the division symbol into a multiplying symbol. There's one little step that we have to make. And so that's why I want to point out, when we turn it into a multiplying problem, the first fraction, or the dividend fraction, then the fraction being divided, doesn't change. Notice it's still a over b in the division. It's still a over b in the multiplying. But here's what does change. With my green highlighter, I'm going to circle the second fraction, or the divisor, and I want you to notice that when it's in its division form, it was c over d. When we changed it into a multiplication problem, it now became d over c. We flip it. We flip that second fraction, and that way it's now a multiplication problem that we can proceed forward with the same way we were taught in 5.2. All right, so let's make a few little notes on here, and then we'll do some examples and learn a little more later. I dropped the cap to my highlighter. Hold on a second. Don't want that to dry out. Okay, here we go. So with my dark blue pencil, I'm just going to draw a little arrow right here to show that, notice that nothing changes in the first one. But from this one to this one, something fairly significant changes. And I'm going to write right here, flip it. Okay? That second fraction, we flip it. Now, flipping that fraction has a mathematical term that we're going to talk about. It's important that we know these mathematical terms so that we can speak about math using proper terminology. So we'll get to that in a minute. But right now what I want you to see is just the simplicity of when we are going to divide fractions, we rewrite the first fraction, we change the symbol from a division symbol to a multiplication symbol, and then we flip the second fraction. All right, that's all there is to it. Then we proceed as if it is a multiplication problem. Coffee. Okay, all right, here we go. So I'm going to take my dark blue pencil again, I guess. We're going to write a couple of notes over here, talk about what this flipping situation is called. All right, so I'm going to write here, we don't really divide fractions. Okay, we can't really work with them in that way at this stage. That kind of changes much later in your math knowledge, but at this stage we're gonna just talk as if it's not really possible. All right, okay, so then next note I want you to write is we turn them into, okay, I'm just going to put a little X here for multiplying. You guys will know what that means, okay? We turn them into multiplying problems, all right? But, and with my red pencil, but the second fraction. And I'm just saying second fraction because that's how they're going to be ordered for this lesson. But we should remember that second fraction, what I really mean is the divisor, the fraction doing the dividing. The second fraction gets flipped. Okay? The second fraction gets flipped. That's what we talked about over here. All right? Now, with my light blue pencil, I'm going to make this little note here. We call this and here's a new word for most of you, reciprocal, okay? Reciprocal, R-E-C-I-P-R-I-C-L, okay? We call this the reciprocal. I wonder if I can highlight that word. Yes, I can. You can still read it. Oh, good. All right, we call that the reciprocal. All right, so here's an example of what that word means then. If I wrote the fraction 1/2, and then I'm going to say that that is reciprocal of 2/1. Okay? 1/2 is the reciprocal of 2/1. 2/1 is flipped from 1/2. That's all that means. The reciprocal of any fraction is that fraction flipped. All right? So actually what we would say here, because we know any number over 1 is really that number. This is not a properly simplified fraction. Properly simplified, it would be 2. So we could say the reciprocal of 1/2, we should, the reciprocal of 1/2 is 2. Okay? But that works for any fraction. I could say, what is this? The reciprocal of 15/16? Well, the reciprocal is 16/15. But that is an improper fraction, so you'd turn it into a mixed number. The reciprocal then of 15/16 is a mixed number. But usually when at this stage, when we're talking about a reciprocal, we're talking about just simply flipping the fraction. All right? That's what reciprocal means. So when we're doing the actual problems, thought bubble that I like to write down here that we use to make sure we can remember the steps for doing this. Let's see, I'm going to use my red one right here. Let's see, if I put, let me plan here a second, hang on tight. Yep, that'll work. All right, so I'm going to, in big letters, I'm going to write copy. And then I'm going to write times. And then I'm going to write flip. And with my light green, I'm just going to put a little dot in front of each of these. These are steps. All right. Copy times flip. Copy times flip. That's what we're talking about when we are dividing two fractions. So I'm going to make my little thought bubble here. To remember, when I'm dividing fractions, I'm going to be thinking copy times flip, copy times flip. Well, what does that look like? All right, well, let's do a couple of problems here, and we'll see exactly what that looks like, okay? All right, so first one we will start with is 3/4 divided by 1/4, okay? Now, we can't actually divide 3/4 by 1/4 as it stands. First, we have to copy the first fraction as it is. That's the copy of our copy times flip. The first fraction, we just copy it right over. Then, times, we change this division symbol into a multiplication symbol. Copy times, now it's flip. Flip, we flip that second fraction. Copy times flip. Now we have a multiplication problem that we can work with the same way we learned how to work with in lesson 5.2. Okay, so I'm going to do a little bit of marking up on this one just so that I can remember how this is all working, right? So the symbol here changes Note that, okay? That changes. There's my red, okay. And this one here, flip. All right, that one there, flip. Okay, I'm gonna put a little green circle around that flipped. All right, copy times flip. Now we're ready to go ahead and see if we can cross-reduce this problem. So I have a 4 and a 4. Yes, those can be cross-reduced. Anytime you have two numbers that are the same, you know that number can go into itself once, and that number can go into itself once. Now I have a 3 and a 1. Anytime one of your numbers when you're trying to cross-reduce is a 1, you know there's nothing more you can do with it. It's already in its simplest form. So now we have 3 times 1, which is 3, and 1 times 1, which is 1. And we learned yesterday that 3 over 1 is not in its simplest form. All right, we know that any number over 1 is that number. So the proper answer to 3/4 divided by 1/4 is 3. And now that I know this is in its simplest form, I will circle that in red. That's the answer to that problem. All right, so copy times flip. All right, let's do a couple more. All right, next one. Next one is 1/2 divided by 1/14. All right, copy the first fraction times, change the division symbol to a multiplication symbol, flip the second fraction. I've got 14 over 1 equals. Now, can I cross reduce? Well, I've got a 1 and a 1, so there's nothing I can do about that. But I've got a 2 and a 14. 14's an even number, so I know 2 is going to be able to go into it. 2 goes into itself once. Oops, here we go. Hold still, paper. 2 goes into itself once, and 2 goes into 14 7 times. So now I can multiply my numerators across. 1 times 7 is 7. 1 times 1 is 1. 7 over 1 is not simplified. We need to make that simply 7. And our answer then is 7. All right? Okay, so one more. 1/2 divided by 3/8. 1/2 divided by 3/8. All right, so copy 1/2 times, change that division symbol to a multiplication symbol, flip the second one. We've got 8 over 2. Now we're multiplying. Check for any cross-reducing. Nothing I can do with 1 and 2, but 2 and 8 I can. 2 goes into itself 1 time. 2 goes into 8 4 times. All right, now I multiply the numerators across. 1 times 4 is 4. 1 times 2 is 2. That is an improper fraction, so it is not fully simplified. We'll divide 2 into 4 2 times. There's nothing left over, so we've got a whole number again for our answer. Whoops, I think I made a mistake there somewhere. Where's my mistake? 2 goes into itself 2 times, 4 times, 1 4, 1 2. Oh, no I didn't. Oh well. Sometimes I think I make a mistake and I wonder what the heck happened. Okay. All right, so if you ever find that I do make a mistake when I'm teaching these lessons, would you message me so I can fix it? You know, I'm doing these just on the fly, live. It's always possible that I would make a mistake. So I try not to, but if I do, hey, catch me and let me know, please. Okay, so that's how we divide fractions. Okay, so let's look at some practice problems for lesson 5.4. Here's the beginning of them. You might want to pause here while you work the first few, and then in a minute I'll move the paper so you can see the last of them. Okay, so here's the remaining portion of the practice problems. Okay, let's work out these problems. I'll show you how they go. All right, so dividing fractions. Let's remember from our notes the steps of copy times flip, correct? All right, so here our problem number 1 says 6 divided by 3/7. So we're going to copy the first fraction. Times means to change the division symbol to a multiplication symbol. And then we will flip the second fraction. So that makes the 3/7. Reciprocal of that is 7/3. Our next step then is to cross reduce if we can, and we sure can. With my 6 and my 3, I know that 3 can go into itself once, and 3 can go into 6 2 times. And anytime I see matching numbers, I know those immediately just turn into a 1, which makes our multiplying now much easier. So multiplying my numerators across, I have 2 times 1, which is 2, and 1 times 1, which is 1. 2 over 1 is not in its simplest form. We reduce that to 2. All right, and then if you're in Mrs. Walker's class, you know that we circle our final answers in red. All right? Okay, number 2 is 4/5 divided by 2/15. So copy the first fraction, that's my 4/5. Times means change that division into a multiplication symbol. Flip means write down the reciprocal of 2/15, which would be 15/2. And cross reduce, let's see, yes. 5 goes into itself once, 5 goes into 15 3 times. 2 goes into itself once, 2 goes into 4 2 times, and now I can multiply across. So 2 times 3 is 6, 1 times 1 is 1, and as we saw in problem number 1, a number over 1 is not simplified. It becomes simply the numerator. So the answer to number 2 is 6. All right, number 3. 5/7 divided by 1/2. So 5/7 divided by 1/2. Okay. Copy the first fraction. Times means change this division symbol into a multiplication symbol. Flip means find the reciprocal of 1/2, which is 2 over 1. Now, cross reduce. Anytime I see a 1 in my pair, the 5 and 1 here, I know it's reduced as far as it can go. 7 and 2, no, there's nothing that can go evenly into both of those numbers to reduce them any further. So there's no cross reducing I can do on this problem. So I will multiply the numerators across. 5 times 2 is 10 over 7 times 1 is 7. Now we have an improper fraction, and we know we can't leave it that way. That's not fully simplified. So 7 goes into 10 once, with 3 left over, and we scooch that denominator right over. We keep it. So our final answer for number 3 is 1 3/7. All right, let's take a look at problem number 4. That's 4/5 divided by 1/3. So copy the first fraction, times, change that division to a multiplication symbol, and flip, get the reciprocal of 1/3, which would be 3 over 1. Okay, again, I'm looking to see if I can cross reduce. I have a 5 and a 3 here. There's nothing I can do with that. They are as simplified as they can be. And a 4 and a 1, well, anytime 1 is one of my pair, I know that that's as reduced as it can get. So, no cross reducing to do on this one. 4 times 3 is 12. 5 times 1 is 5. That's an improper fraction. It needs to be reduced. So 5 goes into 12 2 times. That would be 10. So that leaves me with 2 left over. And scooch the denominator right over. And so my final answer, 2 2/5. All right, problem number 5. 2/3 divided by 1/2. Copy the first fraction. Times, change the division to a multiplication, and flip, get the reciprocal of 1/2, which is 2 over 1. All right, so again, it doesn't look like there's anything I can cross-reduce. The 2 and 1 here, there's a 1, so I know that that's as far as it can go. 2 and 3 here, there's nothing that can evenly go into 2 and 3, so that's as reduced as those two numbers can get. All right, so I multiply my numerators across. 2 times 2 is 4. 3 times 1 is 3. That's an improper fraction, so it is not simplified. 3 goes into 4 one time with 1 left over. Scooch that denominator right on over. We keep it. And so our final answer there for number 5 is 1 1/3. Okay, so final problem on our practice problems is a word problem. It says that Shiloh drives 3/4 of a mile to school each day. There is a stop sign every 3/8 of a mile. How many times does Shiloh have to stop on her way to school? So these problems, when we know it's division because that's what we're working on in this lesson. Later we can talk more about how you tell the difference, whether it's going to be a division problem or a multiplication problem. We know this is going to be division. This is a division lesson. But there's still the answer that many students are trying to figure out. Well, I have these two fractions here, 3/4 and 3/8. I know those are somehow going to be involved in setting up my division problem. But how do I know which one goes first? Which one is the dividend and which one is the divisor? Right? So when you're thinking this through, 3/4 of a mile to school each day, that's the total amount that she drives. Now every stop sign, it's 3/8 of a mile. Okay, so the total amount of something, or the whole of something, or the complete of something that is going to be divided into pieces, that's your dividend. That's the fraction that goes first. She drives total 3/4 of a mile to school. So that's going to be our dividend, our first fraction. That's going to be the number that gets divided into pieces. Well, how many pieces is it being divided into? 3/8 of a mile. We want to know how many times can 3/4 be divided into 3/8 of a mile. Okay, so 3/8 of a mile becomes your divisor, or in this case, your second fraction. All right, so that's setting up our problem. Now we go back to working out dividing two fractions. So we know that we copy the first fraction. Times means change the division symbol into a multiplication symbol. And flip means find the reciprocal of 3/8, which is 8/3. Flipped. All right, now we're going to look to see if we can reduce this before we multiply. And we sure can. We have matching numbers here, so I know that 3 goes into itself once and 3 goes into itself once. 4 and 8, oh sure, because 4 goes into itself once and 4 goes into 8 two times. So now we can multiply across. 1 times 2 is 2. 1 times 1 is 1. That is an improper fraction. It needs to be simplified into simply 2. And that tells us then, how many times does she stop on her way to school? 2 times. So we need a sentence here. Shiloh stops 2 times. Shiloh stops 2 times. You want to get really complete. You could say Shiloh stops 2 times on her way to school. That's good enough for me. So, okay, so those are your practice problems for lesson 5.4. Let's take a look then at what your worksheet will look like. One of the things that I want you to keep in mind is how you must show your work. All right, your worksheet, the top portion of it is all just a mix of dividing fraction problems. And then at the bottom here is 4 different word problems to figure out. So again, pay attention to what is the total thing, and then how many pieces is it going to be divided into, pieces or parts. The total thing is your first fraction. The thing that is the pieces and parts is your second fraction. I hope that makes sense to you. But pay attention here to how you must show your work. It's just like we did in your notes. I want to see how you copy times flip, how you cross-reduce before you multiply across, and double check that your final answer is fully simplified. All right, so that's your worksheet. That gets us then to your exit ticket for lesson 5.4. Exit ticket right here. Let me zoom in on that for you. You may use this as further practice. I don't give you the answers to these, so you may want to get with somebody to compare your answers and or ask your teacher the next day. And your teacher may use these at some other time for some reason, so these are here just for your extra practice. Okay, so that's the end of lesson 5.4. Remember, the only way to learn math is to do math, and mistakes are proof that you're learning.